Thanks everyone for joining today. This is part two, or we'd call the sequel from 1 week ago, where we talked a little bit about the value or the TCO that we see out in the field with our customer base. And we went through a couple of different use cases at a high level. Today we're gonna hit the meaty part of this. We're actually gonna really talk about a lot of different use cases today from our own experiences. Sean's experience as far as bringing Cockroach live into an organization, about all the fun things that he learned along the way and the decisions he made. And I'll talk about some of the things I've seen with some of our customers as well. So I think we're going to break it down into basically two parts, right? Mm-hmm. When I think about use cases, especially in the database world, it comes into two parts. One is the database as a service approach, right? Being able to get a database out to the masses so that any developer can start using it and get that going. I consider that kind of like an initial use case, because there's an audience around that as far as who has to set up that service and how do they deliver it, how do they provision, secure, audit, and all those pieces to it. And then there's the other one, the other major use case category I would call it is all the application things that you want to do. You want to do inventory management, you want to do identity management, you have an application that needs to serve up messages, whatever it might be. Those are a whole nother class of different use cases. So we're going to go into two parts of them. I think we're going to start with the database as a service approach today. And then towards the end, we'll get into more app specific types of things, but that's what you're going to see today in the show. Sean, let's put you in the ringer here a little bit. Let's understand, how you've worked with Cockroach in the past, and maybe just start, like, why did you choose Cockroach, primarily for, the where you worked in the past and how you brought it to life? Why'd you choose Cockroach?
So there's a couple of reasons. Some of it was a little bit of familiarity with, in the sense that I've been tinkering with it and used it, I guess I'll say job -2. And we used it for a multi-region control plane. And it was really that was a really important story for consistency and whatever else. So that gave me kind of a base to work from. But when kind of push came to shove, we were running into some scale challenges and really needed to kind of push the limits of what was possible with Postgres. I mean, I don't call it the existential, but certainly like the engineering challenge of the day was, do we go and embark on a massive, multi-100 person engineering effort to go and add sharding? Or do we go and kick the tires on Cockroach as an alternative in order to not incur that engineering cost and instead, incur an operational cost of operating and onboarding a new technology such as Cockroach, which is ultimately what we ended up doing. And the reason was, pretty simple. It was all about scale. Like we just were at that point running into the limits of the amount of data that we could push through a single Postgres server. And, there were all kinds of complicated issues that we were running into. Some of them were stability issues. Some of them were latency issues. Some of them were replication lag issues. And some of them were just general stability issues, which were, I guess a little bit surprising on some level, but certainly not surprising when you really start to push the limits of a technology. Like when you get to the limits, when you're like a Six Sigma kind of customer of something on a bell curve, like you're going to end up finding the edge conditions and boundaries. And that's kind of an uncomfortable place to be because you're really riding the edge of that wave. And so as far as how and why, we had multiple microservices and we needed to put together a, holistic strategy. That we had a couple of different distributed databases that were at our fingertips to kind of investigate. We had, sufficient expertise, ran down the list for what it is that we needed to do, made some pro cons and built out a database as a service kind of platform team effectively that was really centered around Cockroach. I guess the last little bit to that is as an organization, because we had many different types of databases in-house, what we decided to do was rally around the phrase more wood behind fewer arrows. And we wanted to, double down on the expertise that we had and become really proficient at a, very, very small set of technologies. So that, if you've got a hammer, all you've got is a hammer, everything looks like a nail. How far could we stretch and make use of that? Because then you've got familiarity across a very large engineering organization, and operationally, you don't want to have to learn a new technology for every new niche application.
Yeah. So you're essentially trying to do more with less, right?
I didn't want to say that.
But that's great. I mean, talking about how, trying to avoid, sharding exercises and scale exercises, and thinking of those things when you're building a database as a service platform. So as you did that whole build out, like how long did it take you to get that whole type of service stood up where you can start bringing on some of your first tenants or first applications?
I mean, the hardest part was not actually kicking the tires on Cockroach. The hardest part was actually integrating into all of our operational readiness, and security posture and everything else of that nature. So that took, several months for us to kind of work through, but those were internal issues as opposed to external issues, like, with Cockroach itself. I think we got the tires kicked on an MVP of Cockroach within like 2 weeks, 3 weeks kind of a thing. Like it was where we were running like, a few 100,000. We went from nothing to a few 100,000 QPS in a really small amount of time, with some sample workload. So that part was pretty quick. Certainly like the long pole in the tent was getting everything up and running, and integrated with the rest of the organization. That, I don't want to say it was a surprisingly large amount of time, but like that is certainly an important part of adopting any technology. Is like, how do you integrate it with the rest of your support infrastructure, as an organization that's doing an online service? So after that, then we had kind of like a general database as a service kind of platform, or like, the rough outlines of it.
Yeah, I've seen the same thing. So I've a couple of banking institutions that have done the same thing, and sometimes almost spent an entire year just going through compliance and audit and all the security things, even though the whole platform is already done. So yeah, that's sometimes
we see that regularly right now.
Yeah,
and that's just that is entirely normal, right? But like it is certainly a thing.
Yeah, at least there's less friction on our side as far as being able to get these things up and quick. But yeah, so if you think about that whole experience, what was it like? Maybe not just like we'll do both. Like maybe tell us about like the first app that you got on board that you were super proud of, and then maybe the fastest one that you got on board that you're also really proud of.
Yeah, let's do the fastest one, just because that one's I'm saying more interesting. The one that I'm the most proud of is like, that was the slow and steady mission critical workloads, and those take the longest. And so the story is it's very much an issue of iterate and making. Well, let me do that. It's about making incremental progress. So in this particular case, the development of the application started with a monolith, and then it went to a distributed monolith, which is kind of a scary place to be, where you have the monolith and everything is synchronously and tightly coupled to a bunch of macro services, microservices, like larger microservices, whatever. And you have this like synchronous coupling, which means that, now the number of failure points in your application has gone up effectively exponentially. And so that's kind of a scary thing. And then you finally transition to microservices as well. In that ecosystem, because everything started up, application ecosystem, because everything started as a monolith, you had a bunch of different microservices that were all talking to the same set of databases. Right. So in order to make a technology change like this, you had to go in and complete the execution of the decomposition of the monolith into complete microservices, where not only did the data move to the microservices appropriate, database, you also had to make sure that all callers of this also now routed through the appropriate API service. And when you hit millions of lines of code, it just takes a long time for that to, happen. So there was a lot of incremental steps there. I mean, 1% better every day kind of a thing. Like it really was a story of like, find the next thing, file away the rough edge, go to the next thing, find their next rough edge, file it away, and, just get on this treadmill of continuous improvement. And at some point in time, you get to the point where you kind of like realize that the last burr is gone and it's kind of smooth sailing, and you've actually, made the transition and are able to see the organization fully benefit from the technology without any kind of like hiccups or bumps or whatever. And watching kind of mission critical things go through peak traffic and watching them handle, responsibly and correctly is pretty awesome. I think kind of the showcase for that, the demonstration that we did was we had a peak hour of traffic where throughout the entire week, bar none, did the most amount of database queries, database traffic. And in that exact moment, it was like, wonder what's going to happen if we go and add a new node. We not wonder what, like we knew exactly what was going to happen, but we did exactly that and added new nodes in order to increase capacity at peak traffic and watch the CPU utilization of the entire cluster just go down like, it's not a massive step function, but like down by like 5%, and watch all the queries and data spread across. It was really neat to watch kind of like the graph and all the lines kind of converge as, Cockroach was up replicating and other nodes that already had extra ranges were down replicating because there's new extra capacity, and then all of a sudden you watch the CPU just kind of like slowly start to come down from like 60%. You're like, "Ooh, this is great! This is like welcome to the future." A whole bunch of people that were in like this war room Zoom call watching this, and we got to watch it, and everybody's just like, "Cheers!" This was pretty cool. So that was probably the neatest, most satisfying one, just because it was really like under stress. It kind of like when it mattered the most, the ability to go and walk through that exercise and then have it just work. It was just like, this is pretty cool.
Yeah, especially when you have a database as a service, right? You want to be able to do those scaling things without having to have downtime or fail over to a bigger environment or something like that. So the fact that you could just do that and elegantly things just kind of spread out and see the CPU goes down, that's fun. That's a good time.
That was pretty neat.
Cool. One other thing. So, as you build, I'm sure you agree with this, but as you build a database as a service, a big important piece of it is having applications and groups that want to use the service, right? That they know the right use case to, to apply here and make sure they're doing things properly. Were there any things that you did, any key things that you did that others should know about as far as how you got, not just advertise, tenants, hey, come use our platform, but attracted the right audience, that they're bringing the right use cases and the right workloads to the environment?
In that particular case, I think that we most of that was done through kind of education. We did effectively like an office hours like thing where we trained up internally a collection of experts that were able to scale out, and then we did a lot of office hours, and we're like, hey, come bring your questions, and open door, like one of my favorite quotes is, there is no such thing as a stupid question. If you don't ask a stupid question, you remain stupid. I'm sorry, I totally got that wrong. If you ask a stupid question, you may feel stupid. If you don't ask a stupid question, you remain stupid. And so like, took this attitude of like very welcoming of like, just ask, it's completely okay. Like, this is new technology, new questions. So like, even if you think like ask, even if you don't know, ask, like just ask, and got a very high level of engagement with folks, so that all of a sudden kind of like the cultural diffusion of this understanding started to really push through the organization. And it took a while, like in order to kind of like get good level of permeability throughout the entire organization. But that I think education is really kind of like the thing, so that people feel comfortable.
Cool. That's really awesome. What about any other words of wisdom that you'd give out our audience about, hey, if you're thinking about doing databases as a service, here are the key things that you need, or you want to, you just mentioned education, but what are some other things that people should look out for so that they could be successul with,
this was actually going to dovetail into your other question, which was like, how do you do something that's customers that what was your favorite, like onboarding story, I think is what was the other one that you had there? It's basically getting ahead of problems by doing schema review. Like, this is the biggest piece of advice that I give effectively everyone. And so in this particular case, two things happened. One, this customer showed up, or internal customer showed up on Tuesday and was like, I need a cluster. I'm like, okay, great. So they stand up this cluster and they're like, I've been developing this workload. We have this incredibly short timeline that's externally driven. Like, if we don't do this, there's regulators that are involved, and like, it's super critical from a timeline and execution perspective. So, been developing it, did all the development on my laptop, right? Famous last words. And any major large system, I tested it on my laptop. It worked fine. So in this particular case, did all the development locally on their laptop, said, I need a cluster. We have to be live by Thursday. We're like, okay. it's Tuesday, and I'm like, well, can we look at your workload? Can we go and review stuff? And so, like, just because this is a really short timeline, and like, you don't want to have a big, miss in this regard. In this particular case, like, there was a handful of changes that need to be made to the schema. We were able to get their cluster and their workload up and running. And from basically laptop to hundreds of thousands of operations per second in effectively 48 hours. And so for the total amount of time, planning time, infrastructure time, application time of like effectively 48 hours to operationalize and have something go live at that kind of large scale was, I think, pretty impressive to watch. And it really boiled down to making some schema changes that didn't change the application. It was really a matter of like changing out the primary key, changing out some of the indexes. I think there might have been like a query that we wanted to like, ended up making a recommendation to have something align on an index or whatever. So for range scanning, but that was effectively it. Right. And then like off to the races. And it was like kind of unheard of, right? If somebody showed up and said, hey, I want to do like, I think it was like 300,000 transactions a second, and you had 48 hours notice, you're going to be like, I'm not sure about that. We're going to be able to do that. That's a really short time to go and plan and like, uncover whatever. And it is, but it's also doable.
Yeah.
And so that was a really big, neat success story.
That's awesome. Sometimes you wish you could put that in a trophy and just put it on your shelf. And that's a great story.
Yeah, no, it was a lot of fun. So
yeah. Cool. I can relate to a lot of this. I've seen some similar kind of things.
Yeah, I was like,
working with other
go ahead. Yeah, so for like, for other customer migrations and things of that nature, like, what have you seen there that's kind of given you pause or been interesting to watch, kind of unfold at arm's length?
The last one you just mentioned, like online schema changes, like that's a big one. And actually, before I even get to that, let's put up our next poll. So our next poll, I think, is going to lead into this a little bit. But online schema changes, like I had one customer in particular that really latched onto this. They were building a net new service. The funny thing is that they were database people. Not that they're funny, but it was funny that they're a database company using a database for their service, and they knew databases extremely well.
Yeah.
But the one thing they valued a lot was online schema changes, because all they have to do is just they're going to have so many, new features or app changes happening. They want to do that with the least amount of friction as possible. So if they have a live app and they can push these changes, there's no downtime, there's no extra coordination. And especially when you're thinking about this from a DR standpoint, right? I don't have to do it on the source and the target, make sure things are aligned with the data synchronization process. You just do it in the cluster. It's highly available, all good to go. So that was like one of the first times where I never realized that would be like that high of value for a particular customer, where it was really like the top level thing that they found as useful within the database. We always thought about other things like multi-region consistency, SQL. But yeah,
I mean, one of the ones on the schema change, like the fact that you can do like an alter table add column not null with default and have that be an online operation, for better than 20 years, I'm used to that being an exclusive lock and causing outage, right? Some ORM is going, like some developer is going to go and add something to their ORM or whatever it is. It's not something that you want, but somebody's going to come through with an alter table add column not null default. And that's an exclusive lock in most databases. And the fact that that's not anymore is kind of a big deal. So
yeah.
So you want to talk about kind of some of your migrations there that you've like seen, or like, customers that have been able to avoid sharding or?
Yeah. I know sharding was one on the list, but it comes up every now and then. And, and you kind of mentioned this of what you saw as well. So, sharding is a big deal, right? Especially if you're getting to that point and you have to prepare for it. It's nice, all this gymnastics to make things work. And then your database team doesn't have to do the same set of gymnastics as far as how they're going to coordinate backups and how they're going to split up the data and manage all that. So, I want one customer in particular. Actually, this is funny because this was their motivation. They came to Cockroach because they didn't want to shard. They had success with it, and they had added other use cases onto it. And then the problem that they then had was, oh man, we never thought about database as a service, right? So they had all these app teams come on, started using Cockroach, loved it. But now they have all these different teams that are kind of siloed because they're all doing their own thing. And now when they have to do, coordinate upgrades and so forth, everything's kind of siloed out, which wasn't great. So the next best thing that they found was like trying to just do, how can I find a database as a service that can help me address all these things? And fortunately, the timing was right. This was when we delivered our managed service offering, our dedicated offering.
Yep.
And they found that to be the second win that they got with us, is that, hey, we can just have Cockroach just manage it all for us. And then we don't have to be the DBA. We can just use a managed service, let our app teams do what they're doing, and, just have, a much smoother operational model for our future deployments.
I think that one of the things that you're touching on there that's interesting is just, and I think I might have said some of this stuff, but it's just so true, is because Cockroach is a distributed database, it allows for the decoupling of the use of Cockroach from the operation of Cockroach, right? And with sharding, what you're seeing there is effectively a layering violation where the operation of the database is now a leaky abstraction where you can't scale this resource any further, and you have to push up into the application in order to push this activity into the application so that, from a business perspective, you have a coherent application. Imagine like order IDs or customer service operations or data pipelines, all kinds of issues now all of a sudden become application concerns, but really we're just talking about an operations concern, right? Like we just can't scale the hardware any further. And that's, it's a natural limit, like it's okay. But it's the decoupling that organizations really kind of start to benefit from, the zero downtime, the maintenance, all of these kind of things that happen below the water as far as operations, which historically have been application level concerns where you have to boil all these concerns up to the application, up to the business, all the way up the stack. And you don't need to do that anymore. And so it makes building databases as a service or database platform kind of organizational systems very appealing and tractable problems now, as opposed to previously where you have to go and coordinate every single layer of the organization from top to bottom in order to get alignment there for what's a fundamentally a database hardware operation or maybe a software operation, but something that is not an online operation. And you see all of this coupling come out.
Yeah. And we see it all the time. There's other things that get pushed up. Like there's consistency checks, right? Now I have to write that in the application later and my database doesn't do it. Or
application level joins.
Yeah.
I'm gonna go talk to shard 1, shard 2, fan in, do something in application to go join it together.
Yeah. Or even just, I've seen replication too. Like, there's a failover process. The application will handle bringing data back from a message queue or reconciling stuff. And that all kind of goes away with, just the natural failovers that, Cockroach can do for you, where you don't have to push all that stuff into the app layer and expect your app teams to do all this data reconciliation. So, I like the way you decide,
use versus operation. I think that's,
that's
something that kind of came out of just a conversation with a customer, but it really kind of starting to resonate with me, is you have this very tight coupling typically historically, but if you can break that coupling, which you can, all of a sudden you start focusing on use versus operation. And if you use those two constructs as kind of like the base of kind of like language and the way that you organize your application, you have like schema review for the application, you have the operations here, operations and administration, or application administration, they're very different. Like the service tier, it's very, very different way of approaching handling data, handling scale, handling, application development. All of these things just become kind of like different, but very tractable now. And it's a different tool set.
Yeah. I don't know about you. I kind of want to just go build an application right now, just from the ground up and just go have a good time.
There you go. We got a couple of Q&A here. Do you want to kind of run through these real quick?
Yeah, let's do it.
Before we get a little too far into the hour here. These couple of really good questions here. So the first one is we have a few big tables in Postgres where you run a complex query that joins all these big tables along with filtering, sorting, and pagination. Can Cockroach be an alternative to solve latency issues of these kinds of query? Also, will these kinds of queries scale or impact on latency with other data growth on Cockroach? Amazing question. So I'll take kind of a first crack at this, I think, if that's all right. Does it scale? Provided you don't have some pathological schema, generally speaking, you will. And one of the things that is interesting about Cockroach compared to other distributed databases is we, wrote a brand new query planner. Like we didn't copy anybody else's query planner, and we did that explicitly because we have a distributed system, and the cost estimates and the cost, the execution, the planner, everything needs to take into account distributed systems. If you're used to a cost analyzer that is used to dealing with only disk and memory, then you don't have the primitives required in order to deal with predicate push down, or taking a query and decomposing it and pushing it out to all the leaf nodes and having that network cost in play. And we did that, and we've done that. So for running OLAP queries, Cockroach is not explicitly an OLAP query. We are primarily a key value data store. However, we do pretty well, I think, arguably better than we advertise on the tin, with regards to OLAP queries, because we have this distributed query planner that will take parts of your query and push it down to all the leaf nodes. So you have, connection comes into the gateway node goes and does your query plan execution. And then when it goes to execute, it pushes out, all the appropriate it distributes the SQL to all of the other nodes that are involved in the query, which means that you now have parallel disk IO, parallel CPU, and it's running in parallel. It's not running single thread in serial, like walking everything. And so it does, generally speaking, scale pretty well. It doesn't mean that it's a free lunch. You still have to do all of the work, but it means that all that work is being done concurrently across many nodes. And so the performance is pretty, it's as good as you would expect from a general purpose database that isn't over optimized for that particular type of workload.
Yeah, I would say, if you've looked at the optimizer over the course of time too, it's gotten so good. We have... Yeah. There's very few queries we shy away from. I saw a query the other day, I had 12 different joins, doing all kinds of crazy stuff, and worked fine. And then there's other improvements that we have, like with follower reads and even materialized views that can make things even faster. So yeah, bring us your complexity. We're happy to look at it.
Yeah, obviously, like if you're doing like a 12 table join, that's probably a bad candidate for a query to push into production where you're expecting to do like 1 million transactions a second. But like if you're doing OLAP or dashboarding or something like that, and you need to run big queries periodically using follower reads, it's amazing as far as like scaling for a whole bunch of reasons. But also like, the database does really well with that type of workload. Yeah. So then the other question, you want to go for this or?
I actually don't know the maximum transaction size.
Yeah. So what's the maximum transaction size in CockroachDB? So this is, is it in an individual statement? That's what I wanted to get to is like, what is it in the individual statement? Because if you like begin, insert, update, and have a very wide row, I'm going to give you general guidance here and say that you probably want to keep it under like, let's say, 10 megabytes. By default, that won't work. Because inside of Cockroach, we have what's called the max raft message size. And so the individual SQL operations is bounded by that. If you're talking about begin, a very, very, very large number of transactions, at some point in time, you're going to run into problems with retries and other things of that nature. And so it depends on the level of concurrency. I actually don't know if you wanted to do like a single batch transaction, like begin, insert 1 billion rows or something, commit. I'm pretty sure that just works, but like there's going to be other problems where you're going to have like retriable errors or other, kind of like contention within the system. If you're doing like begin, insert very wide row, or doing an implicit transaction, which is like insert or update very wide row, kind of semi-famously, like if you've got if you're trying to do a hybrid SQL, NoSQL style workload where you have like a couple of indexed columns, like in a normal relational database, and then you have like a JSON B column off to the right, and you just use that as your random arbitrary grab bag of unstructured data so that developers can iterate quickly without having to go through schema or whatever else or any kind of review. I've seen that JSON blob get incredibly large. Don't do this, but seen this done, is change the max raft size to 1 gigabyte in order to push something through, in order to fix and repair a schema, in order to bring that, size back down. So like there are limits there. You should, if you're doing anything that's 1 gigabyte inside of a single row, like you're doing something that's suboptimal. And in this case, it was a bug but yeah. Yeah. So application code.
It kind of goes back to how do you quantify what's the maximum transaction size? Is that the row? Is the number of statements? Is it is it a large update? So it's hard to.
Or is it max number of concurrent transactions per second? In which case, like I've seen, not tens of millions, but like, 2-3 million transactions a second. So like pretty appreciable size with serializable isolation. That works kind of like as advertised on the tin. There's things that you have to do to support that type of workload. You can't have unindexed queries and whatever else. But that's a very doable thing.
Yep. Yeah. So multiple ways to answer that question.
Yeah.
There was one last question is if we're PCI compliant. So you'll see this coming up that, our managed services has gone through PCI compliance. So this is something if that's important to you, yeah, it's there for our dedicated service. So stay tuned.
How does Cockroach survive from crashes? Quite well. Didn't really talk about it in this particular case, but I guess some of the other like highlights that I've seen is I've seen nodes die in the middle of peak traffic. And, you'll typically see like a small variation in query latency, but everything kind of self heals at machine time. And so like, as opposed to an operator getting involved, which typically takes minutes, this is something that's done within seconds. I know that there's new code coming or updated code coming in our upcoming release 23.1 that's going to get that down to like, upper bound of like 30 seconds for some of this stuff, for some of the really pathological failure modes. But like the common case is either hitless, especially if it's like a scheduled AWS maintenance, let's say, that is a hitless operation where AWS signals to the process, hey, you're shutting down, whatever else. Like there's zero interruption to that, which is basically amazing to watch happen. Survives pretty well.
Yeah, it does a great job. That's the name. I'll circle back to one other thing on that question. So I was mentioning, one of my customers that does database as a service before, banking customer, and every quarter they have to do basically a monthly shutdown, right? So one data center or network or something's going to get isolated. The operational teams don't know. There's an event that happens, and everyone has to be, on point for, be able to manage the failovers and failbacks and all that and so forth. The team that operates Cockroach doesn't even show up to work on that day because they just let the database manage and self-heal itself, while all other legacy databases and applications, all those teams need to be on point on that Saturday evening or wherever they do that test. So I don't
These
know.
are all 9 to 5 operations now.
Story just to share today.
Yeah. No, these become like 9 to 5 operations, not like, Saturday morning, maintenance hour, 8 to noon or whatever, like, whatever your maintenance window, your historical maintenance window is. It's whenever.
Yeah. I hope this was any other questions?
There's a couple here. Max DB size. I think the largest cluster I've seen was 700 terabytes. And that was only like a 60 node cluster. So I know that I don't recommend DIT clusters that size, but like that's a doable thing. Some of these other ones, I think those are more involved. Pagination, that's a really complicated question. How do you do pagination? Limit offset is not a great way to do pagination, but that is the SQL standardized way of doing that, or standardized. That's the conventional way of doing it. But like even in Postgres or any relational database, really that doesn't work super well. So there are maybe that would be like an interesting application session to talk about how we would do pagination, O of 1 pagination, because that's a doable thing. And I've certainly seen that done with Cockroach or even Postgres, but like you can do that in SQL, but that's not. Let's see. And then in memory OLAP, I do not think that we have that one. I'm not in product. So like, maybe we do have that on our product roadmap, but that's not something.
As far as I know, we don't. But maybe
talk to your rep and they'll relay the question.
Yeah. A lot of the stuff is customer driven. If customers really want this stuff, we'll look at it. And especially if it's across a lot of customers, then we'll consider it, but
prioritize it.
Yeah. But this is great. I know we're a couple minutes over. It's always fun going over because what else is better to do besides talk about databases?
Right.
But yeah, if give us some feedback, let us know if this is what you like. We can always do a sequel to the sequel, and
the sequel.
Well, we can always keep this series going. I like the idea of going through maybe a pagination, webinar one day, or maybe like tips, like good SQL tips and tricks for
do's and don'ts.
Yeah, for the average app developer, or
I think there's definitely a collection of like pretty common FAQs. Like
Mhm.
at this point in time, migrated like, several hundred applications, and like, there are some very common themes to a lot of these migrations. So maybe talking through some of those would be good.
Yeah. Yeah.
So,
well, awesome.
cool.
Sean, thanks again for joining the show.
Course.
Always a pleasure. And we hope everyone has a wonderful week. Welcome to spring. And
Yes.
we will catch up with you in the near future.